Okay, so here we are, another video, another problem. It'll take a few seconds to make sure everything is working. The audio is working. I popped out the chat as well. Audio is working. I popped out the looks good. All right, so this question is longest turbulent subarray. We'll get into that now. So now I've solved a few so far. Did one, two, this will be the third one. Let's see how this goes. So yeah, the other one was not too bad, the solution. What didn't take too long to straighten it out, figure it out. Given integer array, return the length of a maximum size turbulent subarray of array. Excuse me. Return the length of a maximum size turbulent subarray of array. A subarray is turbulent if the comparison sign flips between each adjacent pair of elements in the subarray. Return the length of a maximum size turbulent subarray of array. Subarray is turbulent if the comparison sign flips between each adjacent pair of elements in the subarray. More formally, a subarray, a array of I plus 1, array of j is of array is said to be turbulent if and only if for I less than or equal to k less than j. Array of k is greater than array of k plus 1 when k is odd, and array of k is less than array of k plus 1 when k is even. Oh, interesting. Or for I less than or equal to k less than j, array of k is greater than array of k plus 1 when k is even, and array of k is less than array of k plus 1 when k is odd. Ah, okay. We get 5. We have all these different comparisons. It's turbulent if the comparison sign flips. So if you have one turbulent array, this can be done relatively efficiently. I think so. If you have one, oh, I'll put 1. Oh, okay, I guess. The length of a maximum size turbulent subarray. Oh, excuse me. So it's not necessarily the number of turbulent arrays, it's just the longest one. You can count the number of them too, I think. It's not much harder. It's about the same level of, it's roughly the same difficulty. I think. I could be wrong, but I think so. Oh, okay. No, actually, maybe not. I think you can just take a look at every turbulent subarray and just move, sort of like a sliding pointer type of a thing. Yeah, okay, I think 2-pointer is the way to go. Yeah, just 2-pointer. It's fine. Yeah, there'll be a toggle. Start off with a 1. The array is always at least size 1, excuse me, so I think sliding window is the way to go here. Int A0, B0, int best is 1. So we'll say some kind of for loop here. Another for loop as well. So we move, and there's a toggle. Bool toggle. We say if array.size is less than or equal to 1, return best. Toggle therefore could be array of 0 is less than array of 1. So if array of 0 is less than 1, if it's true, also okay. If they're equal to each other as well. Array of A equals array of A plus 1. A is less than array.size. Increment both A and B. It's another element to this too. I guess I just have to do the following then, really. If array of A plus 1 is greater than array.size, and we just return best. Basically, we need two elements to check the toggle in the first place that are not equal to each other as well. And this has to be array of A plus 1 has to be less than the size. A plus 1, if we went all the way to the end, then we just return best. And then here we can do A and A plus 1. Okay. So toggle's got to be one or the other. So now we have a loop that we're going to perform, which looks like the following. It's going to be toggle equals not toggle. And we're going to increment B. This is if or you have toggle and or not toggle and it's got to be B plus 1 is less than array.size and B plus 1 is less than array.size, and you have toggle and array of B. So if toggle is true, then you need this one, B plus 1. Or toggle and array of B is less than array of B plus 1. Okay. It's a little bit involved, but that's the basic idea. That's the loop. That's how we move B to the right, right? And then we say best equals standard max of itself and B minus A plus 1. Okay, fine. Then we're going to increment A, and we're going to toggle equals not toggle. Toggle backwards again. And we keep going. I think each time we set B equal to A, so we don't actually need this B over here. This is going to be inside of another loop. B equals A, increment A, do this inside of a loop. Toggle equals not toggle. It actually should be, and this is also going to be A plus 1 is less than array.size. Something like this. It's something along these lines. So we take A, we shift all the way down. We figure out what the toggle value is, and then we start, moving left to right while things are toggling. Eventually, we get to a point where this is false and it breaks, right? And at that point, we would want to move A over. We leave B where it is. Now, I think actually what I ought to do is update A to where the break happened. Yeah. Yeah, I think actually this should be inside of a loop as well. I think this is supposed to be something like this. It's a little bit confusing, but it's something like this. So toggle should be equal to, start off at false. And we just say if a plus 1 is greater than or equal to array.size, return best, just stop. I can get pretty easily that this could be, what's the word? Branch predicted out, more or less, branch predicted. And then here, we would take B, so B equal to A. Actually, we could do it this way. If toggle is true, we want it to that check. If toggle is false, we do the other check. Int B equals A. Yeah, so what's interesting about this is actually you can update A to B, really. Yeah, you could actually just go all the way down. I'm fairly sure. And wherever B ends up, that's where A can begin. I think it should be B plus 1, by the way. So let's say you're at some value B and it fails. You're looking for array of B is less than array of B plus 1. Because you failed at that point, well, no, actually you could start off at B. Yeah, you could start off at B. That's fine. Yeah, because it could fail because B is equal to the B plus 1, in which case A would move forward. Or it could fail because it's the opposite, right? You're looking for array of B is less than array of B plus 1, but it could be array of B is greater than array of B plus 1, in which case you actually want to start at that point and continue there. And those are really the only two options. Either it succeeds, they're equal, and that's why it failed, or it succeeds or fails. It's either, if it succeeds, it'll just keep going past. If it failed, it's either because these two are equal or they're the other condition, in which case it'll move past. Anyway, so yeah, something like this I think is what I want. It's maybe not the best, but it's reasonable. I think it works. It's kind of just a greedy algorithm, I think. Yeah, just a straightforward greedy algorithm. Should be fine. Could try some other test cases here. Just 5, 4, 3, 2, 1. Let's make it choppy. Not 5, 1, 4, 3, 2. Let's do the other direction. 1, 9, 2, 8, 3, 7, 4, 5, 6. And then finally, array of I is 0 and array length is 1. So let's just do it just a 0 in there. Okay, let's try these things. I think I got it. I could be wrong, but I could try these things. All right, I'm going to go for it. Again, I could be wrong, but I suspect I got it. Yeah, okay, got it. Sweet. Pretty good, reasonable. not the best, but yeah, two-pointer solution. It's not even really a two-pointer solution. It's kind of just a greedy approach. So submit this 5 times, and then I don't know how long I've been streaming for. I think oops, not a very fast solution. Yeah, there's probably a better way to do this. It's a little bit faster, but it's okay. 90%. Actually, it's not bad at all, really. 3, 2 more. That's 1, 2, 3. I think it's been like an hour. I think I wanted to go till I don't know how long I wanted to go for. What is it? 19 is like 7 p.m. I can go till like 9 p.m. at my time. Okay, it's reasonable. 5 solutions, 5 of these. Okay. All right, I'll stop there. For this, stop there and start the stream again on the next question. So I'll be back. If you like the video, don't forget to like and